Okay, so before we get to our next example with the divergence test, we want to introduce a concept that starts coming up in some of our infinite series problems now, and that's the idea of what are called factorials. Okay, so we begin by defining it. We say let n greater than or equal to 0 be an integer. Let n greater than or equal to 0 be an integer. Then we define n exclamation mark to mean starting with n, multiply from n and multiply by each number below it, and continue that process until you get down to 1. Okay, continue that process until you get down to 1. And that's called n factorial. Now, we make a default rule that 0 factorial is 1. We make a default rule that 0 factorial is 1. Okay, so that's just a default rule. Right? How do I multiply from 0 down to 1? I can't, right? So we make a definition that 0 factorial will be 1. Everything else just follows the formula. So, for example, 4 factorial would be starting at 4, multiply all the way down until you get to 1, right? And simplify. 24 we get as 4 factorial. As another example, 7 factorial be 7 times 6 times 5 times 4 times 3 times 2 times 1 will be 5,040. So you can see that these factorials grow really big, really quickly. Here we are, just 7 factorial, and it's already over 5,000. Okay, now, factorials are built into your calculators, most graphic calculators. You can find it on the TID3, TID4s by going to your math button and then choosing probability, and then it should be one of the options listed. Okay. So we can do that here. If I pull up a TI-84 type calculator, if I want to do a factorial like 7 factorial, I would type my number in first and hit my math button. Okay. And then across the top, I want to choose probability. So option number 4 there, probability. And then let me just expand it down so you can see the menu a little better. So on mine, the first is a random number generator. NPR, that's something for permutations. NCR, that's something for combinations. And then in here it is number 4, factorial. So you can just select it, highlight it, or you could always just type the number for it to automatically do it as well. So there it is, 7 factorial, and you see we get our answer of 5040. Now, this thing grows very quickly, and you can compute any factorial, although it's only going to display once you get kind of big. Like, for example, if we just did 20 factorial, right? It's already so big that it's displaying it in scientific notation, right? So things get big really, really quickly. Now, there is a limitation on most of your calculators, and that is they'll let you do 69 factorial, but as soon as you try to do anything bigger than 69, your calculators do have a limitation on them, and that's because even though, well, this calculator isn't, it's actually displaying it. I don't know what this calculator's limitation is. But most of your calculators will only do up to 100 digits. Beyond that, it's just too big because they store, even though it only displays like, 9, 10 decimal places, internally it's actually storing much more. Stores a number up to 100 digits. So most calculators, standard graphic calculators, once you get to beyond 69 factorial, they tend to break. This one apparently not really being a graphing calculator, but more of a based off an app. Might have some other limitations. I don't know what it is. Okay, so that's how you get the factorial thing on your calculator. Now let's actually turn to a sequence involving a factorial. So let's consider the infinite series, sum as k goes from 0 to infinity of k factorial over k plus 1 factorial. Okay, so writing out the first few terms of this, 0 factorial, again, by definition, is 1, so that would be 0 factorial over 1 factorial would be 1 over 1. And at k equals 1, that would be 1 factorial, which is 1 over 2 factorial, 2 times 1, which is 2. Keep going. That would then be 2 factorial, which is 2, over 3 factorial. 3 factorial would be 3 factorial would be 3 times 2 times 1, which would be 6. And we keep going. Up next, it would be 3 factorial over 4 factorial, plus 4 factorial over 5 factorial, and so on and so on. So what does this look like? This looks like the sequence 1 plus 1/2 plus 1/3, if we simplify it, plus 1/4 plus 1/5, and so on forever. Okay, so that's what we're dealing with here now. We want to talk about the limit of the underlying sequence. Now, k factorial, by definition, would be k times k minus 1 times k minus 2, and continuing all the way down, 3 times 2 times 1. K plus 1 factorial would start with k plus 1, so k plus 1, and then it would be times k, and then times the next smaller, k minus 1, and so on all the way down, 3 times 2 times 1. So what I want you to notice here is that when I wrote out k plus 1 factorial, it was k plus 1 times, and then everything from k downward, which means we can abbreviate that as k plus 1 times k factorial. In fact, we can break it any way we want. We could also write k plus 1 times k minus 1 factorial. All right, and we could write that out any way that we want. Okay? So this is going to be useful and needed as we try to simplify the limit of k factorial over k plus 1 factorial. Okay? So we look at now the limit as k goes to infinity of k factorial over k plus 1 factorial. Okay, so we're going to infinity. Well, this is taking that number. And again, we've already seen as k grows, the factorials grow very rapidly. Just saw a couple of examples, but we know it keeps growing. And so is k plus 1. So this is going to be an infinity over infinity limit right now. But we can simplify by rewriting the denominator as k plus 1 times k factorial. And so the k factorial terms will cross out. And now we have the limit of 1 over k plus 1. So as k goes to infinity of 1 over k plus 1, and that limit will go to 0. So at this point, the divergence test just tells us that this result is inconclusive. We don't know. It doesn't meet the divergence test at least. So it's inconclusive. we're actually going to investigate this particular series, not as it was originally written, but in its simplified version. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 forever. This is actually something known as the harmonic series, and we're going to turn to that in our upcoming examples.